A shattered cosmic framework. The James Webb Space Telescope has unveiled discoveries that are shaking the very foundations of modern science. It was designed to look farther back in time than any telescope before it, to pierce through clouds of cosmic dust, to capture the faint light of the first galaxies, and to answer questions humanity has carried for thousands of years. From the moment its golden mirrors opened to the cosmos, every image and every piece of data has revealed a universe far stranger than expected. Ancient galaxies appeared in Webb's field of vision, galaxies so well formed, so massive, that they seemed to mock our carefully built timelines of cosmic history. Hints of liquid oceans glimmered on the surfaces of exoplanets, suggesting the possibility of life far beyond Earth. Each discovery has built upon the last, stacking wonder upon wonder, until the scientific community found itself at the edge of disbelief. But the most recent findings go further than any before. They don't just challenge small details. They shake the very structure of cosmology itself. For the first time, data from Webb and its legendary predecessor, the Hubble Space Telescope, were combined and compared. What scientists found was not harmony but conflict. The universe's expansion no longer matches the clean, simple models we once trusted. Astronomers now suspect that some hidden influence, something we do not yet understand, is shaping the fabric of reality. This revelation strikes at the heart of a principle believed for over a century. For generations, scientists thought the universe grew steadily and systematically. Its pace was measured through the flickering of Cepheid stars, and confirmed by the afterglow of the Big Bang itself, the cosmic microwave background radiation. Together, these methods gave rise to what we call the Hubble constant, a single number that defined the rate at which the cosmos expands. It was more than just a number. It was the ruler by which the age of the universe was measured, and the foundation upon which cosmology stood. But Webb and Hubble's combined data delivered a devastating surprise. The universe is not expanding at one rate. In some sectors, the expansion is faster. In others, slower. The rhythm of the cosmos is uneven, its pulse inconsistent. This discovery collapses the certainty of the Hubble constant. What once looked like a minor inconsistency now looms as a crisis, a fracture at the core of cosmology. And that fracture widened further with Webb's next discovery. Buried in the depths of time, it revealed a galaxy given the name ZFGS 7329. A system impossibly large. Larger even than the Milky Way. And yet, impossibly young, born only 700 million years after the Big Bang. By every accepted model, this should be impossible. There should not have been enough time for stars to cluster, for matter to collapse, for a galaxy of such scale to exist so early. Nor should there have been enough dark matter to bind it together. But Webb shows it clearly. It exists. And ZFGS 7329 is not alone. Across the early universe, Webb is uncovering titans, supermassive black holes, colossal galaxies, and structures that should not yet have formed. Each one contradicts the theories painstakingly built over decades. Each one whispers the same message, that the story we tell of the cosmos may be wrong. And perhaps, most unsettling of all, the data hints at something even greater. That the universe itself may be a universe of unthinkable possibilities. One scientist, astrophysicist Raghavendra Gupta, has put forward a bold and controversial theory. According to him, the cosmos is not 13.7 billion years old, but more than 26 billion. His reasoning is that the light we observe from distant galaxies may conceal their true age, tricking us into miscalculating the time since the Big Bang. He goes further still, arguing that what we perceive as empty space is not truly empty at all. Instead, matter and energy may be distributed in hidden forms, in ways that defy our dominant theories. If proven correct, His claims would overturn two of the most fundamental pillars of modern physics: dark matter and dark energy. Some scientists dismiss his ideas outright. Others believe he may have uncovered a key to the riddle of cosmic expansion. But one fact remains clear. Webb's data is forcing us to reconsider everything. If the universe does not expand evenly, then something unknown must be exerting its influence. Perhaps it is a new, undiscovered form of energy. Perhaps other universes are colliding with our own. The mysteries deepen with every observation. Webb has spotted galaxies that seem to hold together without any dark matter at all, challenging one of the most deeply rooted concepts in astrophysics. If dark matter is not real, then our understanding of gravity on the grandest scales may be deeply flawed. And then came one of Webb's most baffling discoveries. A vast and unexplainable structure known as the phantom formation. Here, both light and matter behave in strange and unpredictable ways, as though they are being manipulated by some invisible entity. It bends spacetime itself, defying every model of physics we currently possess. Some theorists see this as the first evidence of a new type of cosmic energy. Others speculate it could be the remnants of a colossal inter-universal collision. Even stranger still, Webb detected mysterious energy signals, pulses of light and radiation that do not correspond to any known star, galaxy, or black hole. Some argue they may be exotic, never-before-seen celestial objects. But others whisper a more radical question: could these signals be artificial? The absence of natural patterns keeps the possibility open, however speculative it may be, that we are observing transmissions from some form of higher intelligence. Whether natural or artificial, these signals remind us of one staggering truth: the universe is not what we believed. Galaxies that formed too early. Black holes that should not exist. Phantom anomalies and unexplained energy pulses. Piece by piece, the foundations of cosmology are being shaken apart. Some scientists even suggest that we may live in a special, anomalous universe, a cosmos shaped from the very beginning by unseen influences. If this is true, then the story of the universe we've told for over a century may rest on false assumptions. As Webb continues its mission, each new observation could reveal something that changes everything, from our theories of physics, to our vision of the cosmos, to our place within it. Are we standing on the brink of a scientific revolution that will expose hidden universes, unknown energies, or even evidence of intelligence beyond Earth? Or is this only the first glimpse into an even deeper mystery still waiting to be uncovered? One thing is undeniable: the James Webb Space Telescope has only just begun its journey. And with it, humanity stands at the edge of an era